Welcome to the Explainer. Today, we're going to get our hands dirty. Well, not literally. We're taking some super basic stuff and building a simple electric circuit right from scratch.
All right, so let's just jump right in with a really simple question. How does this thing—
This is an electric cell, but we all just call it a battery, right? Think of it like a little powerhouse, just packed with energy. How does this little battery have what it takes to make this light up?
And there's our goal, a glowing electric bulb. I mean, it seems simple enough, doesn't it? But getting from point A to point B to get that nice warm glow, well, that takes a little bit of what feels like electrical magic.
So, to figure out that magic, let's peek inside our circuit toolkit. You'll be surprised. It really only takes 3 essential ingredients to make light happen.
Okay, first up, the battery again. Now inside, it's full of chemicals storing all that energy. But for us, the really important parts are right on the outside. These 2 little connection points, we call them terminals. You've got your positive one with the plus sign and your negative one. You're going to want to remember those. They are absolutely key.
And here's a cool little detail that a lot of people miss. The bulb, it also has 2 terminals. It's not as obvious as on the battery for sure. You've got the metal casing around the side and then that little metal tip right at the base. And that is the secret, you see. It's how we get electricity to flow through the bulb, not just, at it.
And finally, our third ingredient, connecting wires. Super simple, right? These are basically the roads or the bridges for our electricity. Their whole job is to build a path from the battery's terminals to the bulb's terminals, and, this part is so important, all the way back again.
Okay, we've got our parts. So how do we put them all together? This is where we get to the unbroken path. Seriously, this is the secret recipe to making any circuit work.
So here's the bottom line. An electric circuit has to be a continuous, closed path. Think of it like a racetrack for electricity. The current starts at the battery, it has to race all the way through the bulb, making it glow, and then it has to complete the lap and get right back to where it started. No breaks in the track.
And this shows it perfectly. Look on the left. We've got a complete circuit. Wires are connected to both terminals on the battery and both terminals on the bulb. See? It's an unbroken path, and boom, we get light. But now look at the right side. That path is broken. There's a gap. The electricity can't make the jump, so it can't finish its journey. And no light. Simple as that.
This is the exact reason why a fused bulb, a burnout one, doesn't work anymore. Inside every one of those bulbs is this tiny little wire. It's called the filament. When a bulb fuses, that little wire just snaps, and that creates a gap, breaking our perfect path. But this time, it's broken from the inside.
Okay, so if this unbroken path is the most important thing, that brings up a good question. What materials can we even use to build it? And that leads us right into the difference between conductors and insulators.
And you know what? We can actually test this ourselves with a really simple setup. It's pretty clever, actually. We just build a circuit, but leave a little gap in it on purpose, right between points A and B. Then we can take any object, stick it in that gap, and if the bulb lights up, well, we know the electricity is flowing through it. And that, my friends, is a conductor.
So it turns out that things made of metal, like a steel spoon or a paperclip or even aluminum foil, they're all fantastic conductors. They just let that electricity flow right on through and complete the path. But then you have stuff like plastic or rubber or glass. Those are insulators. They're like a roadblock for electricity. They block the flow and keep that path broken. And this whole idea, of being able to make or break the path whenever you want, that's exactly how a light switch works. It's just a simple device that lets you either complete the circuit or break it. Click, path complete. Click, path broken. It's all about control.
Okay, so we know the rules of the game now, right? So let's try a little circuit troubleshooting 101. Time to put our detective hats on and see if we can solve a classic mystery.
So picture this. You've just built your circuit, you've connected all the wires, everything looks perfect. You flip that switch to on, which is supposed to complete the circuit, and nothing. The bulb just sits there, dark.
So what went wrong? What are the possible reasons it's not working? Let's run through a quick checklist. Well, there are a few usual suspects. First, the bulb could be fused, right? That broken filament we talked about? Or maybe the battery's just dead. All its energy is used up. It's also really common to just have a loose connection somewhere. Remember, even a tiny gap is enough to break the whole path. And of course, the switch itself could just be broken. But really, when you get right down to it, it all comes back to one golden rule. If you want your circuit to work, you need a complete closed path, and it has to be made of stuff that conducts electricity. That's it.
Okay, so now you've pretty much got the fundamentals down. You know how to power one little bulb. But before we go, I want to leave you with a little question to chew on.
How do all these rules we just learned, terminals, conductors, that all-important unbroken path, how do they work when you start building bigger, more complicated circuits? Now that's a challenge for another day.